Welcome out to our big review. We're now in part 2 of several parts where we're going to be taking a look at the requirements for creating a graphical user interface to a very well-designed game that is not only going to be something we can play on our computer, of course, but something we can play on somebody else's computer as well. Part of what I'm calling Wagile 1. Feel free to skip this session if you understand what we're trying to do. But if you don't, this is a great place for you because in our previous session, we discussed how we can split out a network, client and server from our classic game while, most importantly, maintaining the single standalone classic game ability as well. So we're actually creating several games. One, of course, is to run standalone as we always have done with PyTrek 2020, but also to allow us to have a client and the server running as well to create a GuiTui canvas, very much the way we might do with Turtle Graphics or any other technology included with Python that allows us to use the support for the TK and TCL mapping capabilities, which will allow us to map our displays and clients over to what I call something that serves up a RU, or request or response unit, from our service. In other words, we're going to be sending something text back and forth from our view server, and the challenge here is to create a client that will be able to view the server information as part of a rational and so missing change management process. So once we have our network set up, of course, the first thing we're going to want to do is have something to respond to our requests. And since we're simply in the review mode trying to understand what's going on, of course, I suppose we could do a whole lot worse than responding to our requests with our opening screen. We'll copy and paste our response into a string, and we'll simply call that screen 01. Because this is simply going to be a test case, we'll put a TC in front of our name to save it as going GUI before creating a test case server that'll do much the same thing. Opening our run server. The next thing to do, of course, would be to create another server in our test case for going GUI. And this time, our response is simply going to be a screen, which contains our screen, pretty much as we see here. So our feasibility for our server is pretty easy to understand. All we're going to do is return a string. Very little change here, but unlike our textual server, our client is going to have to be able to do something a little bit more sophisticated because we're going to be using Tkinter to display our text upon a canvas. So here again, we've done so many of these before. Let's go ahead and see what AI will do. In this case, we're going to use GitHub, Microsoft's AI default, to create a Tkinter canvas to display an entire console screen buffer received in response to a UDP request. I've had really good luck with this type of query in the past. Let's roll the dice again and see what's happening here. We see we got 800 by 600. Interesting, nice least common denominator. We got a message that we're going to be seeing in our request and our response unit called get screen. They're going to create the IP report. They're going to use the UDP IP and the UDP port and set our request message up to a new Courier fixed pitch font, line height of 18. Well, good enough. Yikes. We're going to bind to an event that's going to allow each one of our lines to be stuffed from a screen buffer after we receive the response. That's not bad. We're going to wait some time there. So let's see what screen buffer does. Very easy. Screen buffer. This is not usable at all, really. the screen buffer is going to check for it, and then we're going to set our timeout. Then we're going to send the message to our IP. Then we're going to receive 65535. Whatever, big size. Once again, 80 by 25. Anything larger would be fine. Going to get a UTF code, and then we'll set our screen load up to a bunch of sprint lines, and we're going to display the screen. But this is really fun. In a way, it brings us some opportunities I hadn't thought about before, because I would have usually simply used the new line to wrap things off into a single text display. Now, I'll show you how to do that in a minute, but here we're going to enumerate through each one of our lines, and then strip it off. Now, this is not really wonderful. Not really wonderful at all. But it was a good try. So what would we want to do if we don't want to do this as the AI thought it would be? Well, there's two ways to do it, in my opinion. One would be simply to have a button to submit our request so that we don't have such a main line mess. I like the idea of having a rasterized buffer and a bunch of lines. That is a console screen by definition, but it's not the only way to do things. So let's say the UDP request will be sent each time a button is pressed. That should do it for now. Nice, there's our button. This should work a lot better. And now we're going to use this display screen. Still like Delta Lambda, and we still look like we're going to have our request. However, it's going to be in response to a button click, in which will display our screen again. Could be one string, it could be many. That's kind of nice. Could have an overflow, I suppose. And of course, they do indeed know that we need to have a fixed pitch font, all being nicely lined up across the top and across the sides in the same fixed pitch way. Downloading the solution and opening it with idle. Let's hack it up a bit to make it work with our existing client server logic. Import everything from IP info so we can keep our IP localhost. And let's set our message size up to 10240, simply because the screen should fit, I suppose, an 80 by, let's make it 25. This 24 is not unusual. And let's go ahead and use a UDP port. And starting our server, let's see how it runs. Not bad, right out of the box. So, oh my gosh, how boring was that? Honestly, when AI gets involved, sometimes you feel satisfied, sometimes you feel like you need to do some more. And some of the more things I would like to do would be to add genuine color to this display so that perhaps some of the text is red and some of the text is green and anything else. But that's going to mean we're going to have to update the screen so as to, rather being a simple character, would have to have another code installed next to any one of those characters to tell us what color it had to be. That'll double our buffer size of 80 by 25 at least, to make things a little bit bigger to go back and forth, but that's a challenge for next time, and one that you might be able to work on in your spare time as your time and interest allows. But more importantly, see if you can get AI to generate up your own TK. Feel free to freeze frame ours and take a look. But the key thing, I think, is to make sure that we're either using a button on the user response, or, as we saw in our first example from AI, which I didn't really like, using a thread, because we're going to have to use both. The ability to interact with the user like we do at the console, typing in long-range scanner, short-range scanner, as well as listening on a thread from our client so as to get some real-world telemetry and add some excitement, perhaps some chatter from other ships or other players, even some other non-player characters or AI, if you would. So both user-driven events as well as threaded listening capabilities are something we're going to want to have as a requirement, in addition to some color, I think, as part of our requirements from WAGile 1.